Okay, so today we're going to cover volume of pyramids, and it's very similar to that of a prism. We're still doing volume of a prism or a cylinder, remember, is always capital B times the height, where the capital B represents the area of the base. Now, what's going to be different for cones and pyramids, it's going to be the same thing, except for we're going to multiply that BH by 1/3. You could also do BH divide by 3, either way. Because if you think about it, if you take a square pyramid and you put it inside a cube, it looks like you're chopping off like 1/3 of the cube. So that's why it's similar to a prism or a cube, whereas you're going to find the area of the base, multiply it by how tall it is, but then multiply that final answer by 1/3 or divide it by 3. Now, when we're doing this, they need to be regular pyramids. And when I talk about a regular pyramid, I'm talking that the base is a regular polygon. So if it's a quadrilateral, the regular quadrilateral would be a square. So it would be a square pyramid. If it's a triangular pyramid, then the base would be an equilateral triangle. So the base has to be regular, all the sides have to be congruent or the same. Here, all lateral edges are congruent. All lateral faces are going to be congruent isosceles triangle. And the altitude is going to meet the base at its center. So remember, the altitude is the height, and there's a picture of it on the next slide. So the green line there, that is the height. It's meeting the base at its center. So here again, the volume of a pyramid, the formula is 1/3 base times height, where that capital B or uppercase B represents the area of the base. So let's try an example. I'll go ahead and try to draw here a picture of a pyramid. It's a regular square pyramid, so I know all the sides are equal. So here is my pyramid, and it's kind of slanted, but you get the idea. So it said that it's regular square with base edges of 6 centimeters. So each one of these are all congruent all the way around. And it also gave me the height, which is 12 centimeters. So the height is 12. So I'm going to go ahead and write down my volume formula. Remember, it's 1/3 area of the base times the height. Well, my base area is a square, so I'm just going to do 6 times 6, and it's 36 centimeters squared. And now that I've gotten capital B, I know my H is 12, so let's just plug it into the formula. 1/3 times 36 times 12, and then I'm just going to multiply. Now, if you weren't using a calculator, I could simplify here, make this a 12, and then the volume is 144 centimeters cubed, or cubic centimeters. So just remember, the units on volume are always cubed. So just find the area of that base shape, times it by the height, and then times it by 1/3. It's probably easier to multiply base and height and then divide by 3. All right, let's try example 2. This time, we're going to have a regular triangular pyramid, and they want us to find the volume. So again, we're going to use the same formula, 1/3 BH. But remember, this time the B, that area formula is a triangle, so 1/2 base times height. Now, these two heights are different, these two H's. One is the height of the triangle, and the other one is the height of the pyramid. So let's do the triangle base. So my triangle base is right here. It's got a base little b of 4, and the height of that triangle is 3. So 1/2, 4 times 3, and my base area is 6 feet squared. Notice that the base is area, that's why it's squared. But now when I go to do the volume, this answer will be cubed. So 1/3 area of the base, which was 6, times the height now, and this is the height of the pyramid, which is 7. And again, you could multiply 6 times 7, divide it by 3 on your calculator. Again, if you weren't using a calculator, we could simplify. 1/3 of 6 is 2, and 2 times 7 is 14. So 14 feet cubed is the volume of this triangular pyramid. All right, so next, let's try to find the height given the volume. So it says find the height of the triangular pyramid. So again, let's write down the formula. 1/3 BH. I need to find the area of the base. Again, it's a triangle. So 1/2 lowercase b times h. The base of the base triangle is 6, and the height of that base triangle is 3. So 1/2 of 6 times 3, again, I could take half of 6, and then 3 times 3 is 9. And these are meters squared. Now again, we're solving for h. So now let's go ahead and put in our volume. It was 24. We just found the base area to be 9, and I don't know the height. Again, I can do 1/3 of 9, and that gives me 3. And now I have 24 equals 3h. Divide by 3, and the height is 8. Now we'll do the same thing we did with the prisms and what we did in the homework with the similar solids. Again, we're going to find one of the linear measures, a height or a side length, put it into a ratio. Then for the volume, we have to cube it. Everybody good on this example? Mm-hmm. So again, just like we did with the prisms and the cylinders, we can find volume of a similar solid when we know 2 of the heights or 2 of the edges, and then we know 1 of the volumes. So again, stay consistent here. So however you set up your ratio for the scale factor, do the same for the volumes. So I'm going to find my scale factor, which is K. So I'm going to do the height of pyramid B, and I spelled that wrong, pyramid B over the height of pyramid A. So I'm going to do 6 over 8 simplifies to 3/4. That's K. Now, for K cubed, which is what I need for volume, I take the 3/4 and I'm going to cube it, and this gives me 3 to the 3rd power is 27, 4 to the 3rd power is 64. And now notice I did B over A. I'm going to do the same thing for the volume. Volume of B, pyramid B, over volume of pyramid A. Pyramid B is what I'm looking for, and pyramid A is 96. And I'm going to set that equal to 27 over 64. I've got a nice proportion to solve, so I'll cross multiply. X times 64, 96 times 27. 64x equals 96 times 27, 2,592. Divide both sides by 64, and x equals 40.5, and these were meters cubed. So this is the volume of pyramid B.
Miss Ford,
Yes.
why did you, when we started off, why did you put height of pyramid B first instead of height of pyramid A?
You can do it. You just have to stay consistent. So if you wanted to do the heights as A over B, then you would do 8 over 6. But then over here, you would have to flip it to 96 over X. It doesn't matter. Just stay consistent. Okay, good? All right, one last example. It's a composite solid. Whenever you have any kind of composite solids, generally you're going to be doing two different solid formulas. And then depending if it's got a hole in it, you would subtract. If they're stacked on top of each other, then you would do the two volume formulas separately and then add them back together. So this composite solid is composed of a cube and a square pyramid. So to find the volume of this composite solid, because every composite solid is going to be different depending on its makeup, but this one, we're going to find the volume of the cube bottom and add that to the volume of the pyramid top. So volume of the cube bottom, again, volume of a cube is either base times height, or, so for a volume of a cube, because it's also a rectangular prism, you could just do BH, but remember your base is a square, so another way to do volume of a cube is just side, and this is an S, not a 5, S to the third power. So here I'm just going to be doing S to the third power. Volume of my pyramid is going to be 1/3 base times height. Now, if side to the third power confuses you, you could just do capital BH as well. So my side length is 6. My base area of the square pyramid, again, is a square. So it's 6 times 6, or 6 squared, times the height of the pyramid, which is also 6. So 6 to the third power is 216. And then 1/3 times 6 squared. So 6 squared is 36. And again, if you want to simplify, make that a 12, making this 72. So the final volume of the composite solid is 288 meters cubed. So that is it for the volume of pyramids.